We are here in sunny Melbourne inspecting some acoustic walls or noise walls that has exhibited some damage that we're going to get to the bottom of. They aren't all that old, so about 10 or 15 years since they were erected, and we're going out on site here to figure out what the damage is, what the cause is, and see if we can find a solution. Before we jump in and take a look at the damage, let's see what we're dealing with first. So this is a typical panel view of a wall segment. Starting from the base, we've got a footing arrangement that directly supports two steel I-beam sections, cantilevering off the foundations. All the vertical load is supported at the base corners of the base panel via two dowel bars at each footing. An interface between the base panel and the footings is provided with a grout bed of 20 to 30 millimeters. And that is the only contact area provided for the wall segment. It is a clear span between the two footing elements. Some recurring damage was seen across the length of the wall are these hairline cracks, which are propagating at the base connection to the footing. As you can see, this coincides with the grout tube that houses the dowel bar within it. This is the most common form of damage that we've found across the length of the panel. In quite a lot of areas, we've seen a grout bed totally deteriorated, as with this example. You can see some movements occurred there with that vertical crack. This is probably on the high side of a grout bed depth, so ideally you want to keep it at about 20 to 40 mil. This is closer to 100 mil, which is probably on the higher side. You want to keep that as low as possible. Ideally, there was a couple of locations where the grout bed was found to be an excessive depth. Some more significant cracking now occurring in the footings at this location. So at some areas the panel was cracking, other areas the footing was cracking as well. You can see this location coincides with the hairline crack on the panel itself as well, which indicates that some damage has occurred to both the supporting element as well as the precast element above. I find that taking videos during inspections are a really great way to review your findings. A picture says 1,000 words. A video probably says 1,000,000 words once you watch it back and get good context. We can see here another crack on the footing beneath the precast panel. This has gone all the way through to the other side. Also see a crack on the panel itself. This is an instance where the top of the concrete pad has started to spall off. We're seeing quite a lot of damage to the grout bed as well. It's just popping off there on the side. Deterioration of the footing as well. It's pretty widespread across the full length of the wall, and this is about a 1 kilometer length of wall, so it's quite a lengthy run. There's plenty of walking out there on the day to inspect all the wall. Nice and sunny day out in Melbourne. You can see here again the grout tube and the dowel connection just so happens to coincide where the grout bed and the precast panel crack and the footing crack meet. Some more significant damage on this example. Again, you can now see the cracks quite evident, definitely in the footing, but then also precast panel above. Quite a significant crack here, almost 1 centimeter wide, and that runs up the full length of the panel. Again, we can see the two grout tube breather holes, which coincides with the dowel bar connection. And as you can see there, it's just a totally deteriorated grout bed. There's obviously something that's gone seriously wrong at this connection detail, and it requires further investigation. As you can see, these panels are getting quite tall now, so the higher the panel, the more damage was evident, given the additional loading and the support. You can see here a clear span between the two footing elements. It's a very distinct load path from the panel self-weight down to the support footings. Here is an even higher degree of cracking as evident. There's even an ant's nest that's found its way within this panel, and you can start to see some really significant failures and cracking through here. Water's been getting in and accelerating the deterioration of the panel itself, and it's just become a bit more of an exponential failure at some locations. Here's a more up-close example of a deteriorated grout bed. So as you can see, the pen just easily pulls out that big chunk of grout. The reason why I'm using a pen is I value my fingers, and there's probably very little supporting the panels. There's probably a packer under the panel that I'm actually trying to find here. I'm trying to dig out and see what's actually supporting the panel. It's probably a mixture of some grout bed area that's still effective. It's probably sitting on its packer, and also probably some load transfer through the dowel bars as well. But as you can see here, it's just a totally ineffective grout bed. That big chunk on the right there is just easily moving about as I touch on it. and that's continued through the other side, and you can see that's quite a significant bearing surface that is now no longer effective. And again, you've got to be really careful with these kind of inspections because there has been a failure that's occurred and it's quite serious, and you just got to be mindful of where you're looking, where you're poking around, where you're putting your fingers. Here's an overall view of a panel segment now, just to give you some context on the size and the scale. This is probably the average height of the panel, so this is a 3 stacked high panel, but as we can see, the damage is quite significant at both ends. This example here is probably the worst damaged area that we saw, so quite a significant crack there, about 1 centimetre opening up on the footing. Don't even need to get the tape out for the panel there, it's totally cracked, and that piece of concrete is now totally non-effective, and you can see it wobbling about there as I rotate it. That's all cover concrete, so there's a bit of congestion on the bottom corner of the panels. You've got a grout tube, you've got a dowel bar, you've got perimeter bars around the edge of the panel and the mesh, and that chunk of concrete on the right hand side now is just the cover concrete that's popped off, and that grout bed's totally destroyed. As you can see, it's just it's a pile of rubble and dust, very chalky, very little that it left is effective. It's totally been compromised. And you can see some corrosion's now started to set in on the reinforcement given the exposure to the elements. Definitely something that needs to be addressed and remedied. So let's focus on another grout bed, do some digging around, see if we can find our elusive packer. You can see there's some affected areas here. There's some rubble that just gets poked away with my pen. So the panel is getting some support still at some areas. Oh, there we go, bingo, there's the packer. So essentially a lot of the load from this panel in particular is traveling through that packer, and that packer has been put there during construction as a temporary erection aid, and that would have allowed the grout to be inserted under the panel and then progressively loaded from above, but obviously something's gone wrong on this occasion at a number of panels. So now let's hone in on the detail of this base connection and some potential causes for this deterioration of the grout bed. As you can see here, the base of the panel has been provided with a chamfer, so that creates this triangulated grout piece on the edge, and that's the piece that we found that was the most easily broken away, and I guess the first stages of deterioration that appeared to be the first thing that went on this connection. So let's take a closer look at this junction. Here's a schematic cross-section of the base detail. We've got the precast panel sitting above the grout bed. The grout bed then sits above the footing, and it's all tied together laterally and vertically by the dowel bars. Now these panels are exposed to the elements, so wind-driven rain can hit the panel on both sides, and this over time can allow rain to travel down the panel and into the joint. So the geometry of the joint with the chamfer actually provides a funnel for the water to find its way into the joint between the grout bed and the base of the panel. The cycles of wetting and drying of the grout bed would cause deterioration over time, over several years, so it's likely that the grout was adequate and sound when it was constructed. However, given the passage of time and elements and moisture finding its way into that connection, expansion and contraction and moisture has caused the degradation of the grout bed over time. The other interesting part of this detail is the load transfer through the joint. So the panel essentially provides a vertical load onto the grout bed and the footing. So as you can see here, that's some vector lines shown vertically of the panel imposing its force onto the grout bed. The areas that are applied to a horizontal plane, the load just travels straight through, which is quite simple. However, a really interesting phenomenon occurs where the chamfer exists. So the angled edge of the chamfer creates this horizontal component of the reaction within the grout bed. And noting that the grout bed is not reinforced, this horizontal component is restrained only by the tensile capacity of the grout bed itself, which, as we know, concrete or grout is quite brittle and hasn't got very much tensile capacity at all. So over time, what we find is that that triangulated piece is really the first thing to go, because there's not a lot holding it in place, and that horizontal component of the load transfer through the grout bed, as well as the degradation over time caused by the moisture, has acted together to start that initial phase of the deterioration of that grout bed. And we saw this quite a lot on a number of panels where that triangulated piece had popped off the edge of the grout bed, and this is probably the first stages of deterioration that we've seen with this detail. So the remaining contact area of the grout bed is left to take more stress and load through that joint, and that further crumbles the material that makes up the grout and starts to chip away, becomes chalky, and that's probably the third degree of deterioration was seen on these panels, as can be seen by these locations here of the previous videos. And to reach such a point where the grout bed itself is really not that effective at all, and it's providing very little bi-load support through that joint. So what we're left to rely on is the actual dowel bars taking almost that whole load, that whole vertical load through that joint. And our assessment has shown that the dowel bars on their own, the two dowel bars at each end, are structurally not adequate to take that load on the panels. So they're likely to have yielded and deformed, and this is likely to have occurred locally at the grout bed location, where the bar hasn't been provided with any restraint by the concrete mass above and below. And if we take an elevation view now of the precast panel arrangement, we've got the precast panel itself, the grout bed and the footing, and the dowel bars holding it all together. Just for context, showing the other view. Once those dowel bars start to yield and buckle, there's not a lot holding them into place, particularly that leftmost dowel bar. As you can see, there's perimeter bars around the panel. However, that L bar, the vertical L bar, hasn't got a lot of development. So there's really not a lot of reinforcement and restraint holding that dowel bar into place, and deformation really mimics that of what we saw in the field, and especially that worst case panel that we saw earlier. So where to from here? So there's a little bit more investigation to do. We got to go to the lab, take a few samples of the mortar, some concrete samples, a little bit of reinforcement scanning. Those will get tested. We'll then be able to verify the strength of the grout, and we'll probably be able to find a bit of a cross section grout deterioration. So there's a number of areas where the grout looks pretty good. I'm going to take some test samples of some good grout, some not so good grout, and some really deteriorated grout, just to get a bit of a timeline on what the likely strength of the grout was when it was constructed, and then areas strength is given the passage of time, deterioration that it works out.